second topic with linear inequalities that we want to touch on is solving linear inequalities. So in each of the examples that we looked at so far, it was already in the form x greater than or less than something. But just like with a linear equation, we could have an inequality that isn't already put into that format. Just like with equations, we have some properties that we can use. We have our addition property. Remember, that's what we have our addition property, which in an equation allows us to move stuff from one side to the other. It turns out we have the same thing for inequalities. Now, I've stated this with the greater than symbol here, but this works for any of the other symbols as well. In other words, if we have an inequality, we're allowed to add or subtract the same thing from both sides, and it won't unbalance the inequality. It will stay in balance. So think of if you had a 40-pound person on one side of the seesaw and you had a 80-pound person on the other side. If you handed both of those individuals a 5-pound weight, it's still going to be unbalanced, right? The 80-pound person plus the 5 pounds is still going to be heavier than the 40-pound person plus the 5 pounds. And that's what our addition property says. So we can move stuff just like an equation by adding or subtracting from both sides. So let's consider an example here. Consider the inequality x plus 7 greater than 20. So just like in an equation, we want to get the variable by itself. So we would subtract the 7 from both sides, and then we would get the result, x greater than 13. And then if we wanted to, we can graph that on a number line. So we can draw our number line. Since it doesn't have the bar, we put a circle around 13 and then shade everything to the right. Now things get a little more interesting when multiplication is brought into play. So we have our multiplication property of inequality. And so before we get to what it is and why it's more complicated, consider the following inequality. 20 is definitely greater than 8. I would rather have $20 than $8. Okay, so 20 is greater than 8. So let's take that inequality and multiply it by 5. So both sides of the inequality here we're going to multiply by 5. So 5 20s would be 100, 5 8s would be 40, and 100 is still greater than 40. So there the inequality was maintained. On the other hand, though, let's multiply the inequality by negative 2. So 20 times negative 2 would become negative 40. 8 times negative 2 would become negative 16. And then we'd have the inequality negative 40 is greater than negative 16. If that was true, that would mean I'd rather owe $40 to someone than owe $16 to them. But no, that's not true. So when we multiply by a negative, it turns out to maintain the inequality, we have to flip it around. So negative 40 is less than negative 16. You're worse off to be $40 in debt than you would be to be just $16 in debt. Okay, so let's see that in an example. Well, that's summarized first, before an example, as our multiplication property. Turns out there's 2 steps. If we multiply or divide by a positive number, then the inequality is okay just the way it is. That's what the first line says. If we have an inequality and a number that's positive, then we can just multiply or divide both sides by that number. On the other hand, if we have a negative number, when we multiply or divide both sides, we must switch the inequality. The inequality is getting switched there. Okay, so we can see that in an example here. Consider the inequality negative 5x is greater than 20. Negative 5x greater than 20. So we can start by saying, well, to get x by itself, we've got to get rid of the negative 5. So we'd have to divide both sides by negative 5. Because we are dividing by a negative, the inequality will invert its direction. The inequality will invert its direction, and we get x is less than negative 4. And then we can graph that on a number line. Draw our number line negative 4 there with an open circle and then everything below. Okay, so that's the important idea here with the multiplication property. We can still multiply or divide to solve, just like we would with an equation, but what we have to remember to do is to change the direction on the inequality symbol.